So we are still in the topic of rationalizing the denominator. However, in this task, the denominator is now a binomial. So it's not just one group of, expression. It has an operation in between. So first, let's read the instructions on how to do it. By definition, to rationalize means to eliminate the radical sign in the denominator. But this time, we are going to multiply by the conjugate of the denominator. So what is a conjugate? Now, a conjugate can be thought of as, a partner, or its complement, or, its counterpart. So they're similar but slightly different. So, for example, the denominator here is 2 minus radical 3. So what is the conjugate? Conjugate comes in different signs. Okay? So they're similar because we're going to use the same numbers and radical expressions, but they're different because we're going to change the negative sign to a positive sign. So how do I write that? So remember that we're still multiplying, right? By the same expression that we see in the denominator. So we copy the 2 and the radical 3, but instead of using the negative sign, we're going to multiply it by the conjugate. So that means we turn the negative into a positive. So this is similar to your difference of two squares. I should write it down over here. So if you remember the pattern for difference of two squares, I think that was the first time I mentioned the idea of a conjugate. So when you're multiplying x minus 2 times x plus 2, right? So they're similar, but their signs are different. And you remember how to find the answer to this one? You multiply the first together. So x times x, and then negative 2 times positive 2. So the correct answer will be x squared minus 4, because negative 2 times positive 2 is negative 4. Now, if you've forgotten how to do this, take note that the box method and the rainbow method also work. But at this time, I think there is value in knowing the shortcut. So if you're multiplying two binomials that are conjugates of each other, then you just multiply the first, you get x squared, and then the last, which is negative 4. Okay, so going back here, whatever we do to the bottom, we're going to do it to the top. So 2 plus radical 3. Okay, now the procedure here is slightly different from what we saw earlier. We're going to use the rainbow method to distribute the 7 to the binomial. There we go, because we are now multiplying a monomial to a binomial, so you have to distribute. So what is 7 times 2? That's 14. Okay, and then what is 7 times radical 3? So the 7 cannot join the 3 inside the radical sign, so you have to keep them apart. So you have to write plus 7 radical 3. There you go. So they are separated by the radical sign. Now let's go to the bottom. Okay, so we're going to use the difference of two squares pattern to simplify the bottom. Since they are the same, 2, 2, radical 3, but one is negative and the other is positive, then we're just going to multiply the same expressions together. And this one also. Alright, so what is 2 times 2? That's 4. Now what's negative times positive? It's negative. Okay, and then what is radical 3 times the radical 3? You know that it's radical 9, right? But what is the radical of 9? It's 3. Okay, so let's simplify further. We get 14 plus 7 radical 3. What is 4 minus 3? It's just 1. So if you divide the numerator by 1, then the final answer will just be the same. There we go. Okay. Some clarifications or questions that I'm anticipating. where did the 3 come from? So let me explain again. The 3 came from here. Negative 3, not negative 3. Radical 3 times radical 3, that's originally radical of 9. What was the radical of 9? That's 3. Okay? Alright, so that's our first example for rationalizing the denominator. Let's continue and do some more. Okay, this is a cube root. So for cube root, I don't know why I included that here, but that's okay. Let's just do it anyway. So if it's a cube root, let's look at the third column. So we can change it into a 64, right? Because 32 times 2 is 64. So let's multiply here by, multiply here by cube root of 2, because we want to change it into a 64. Cube root of 2. Okay, so the numerator will become 5 cube root of 2, and then the denominator will be cube root of 64. But what's the cube root of 64 here? It's 4. So the final answer is 5 cube root of 2 over 4. So that's the final answer. Okay, so let's go to the one that I wanted to show you, the one that has a binomial denominator. So first, let's write down the conjugate of the denominator. So we're going to times it by, I keep putting the equal sign. So let's multiply this by radical 5, remember, conjugate, switch the sign, plus 2. So you're copying this exactly, but change the sign. And whatever you write at the bottom, you have to write it also at the top. Okay. So now, let's distribute. Okay. So 13 and 5 both have radical signs, so we can put them together and multiply them together. So 13 times 5 is 65, right? So that will become square root of 65 plus, now 2 doesn't have a radical sign, so it has to stay outside. Okay, all over. So remember your pattern earlier. You just multiply the ones that are the same, and then these two together. So what's the square root of 5 times the square root of 5? That is the square root of 25. But what is the square root of 25? 5. So we're going to write here 5. Then negative times positive is negative. And then what's 2 times 2? That's 4. Now what is 5 minus 4? That's just equal to 1. Okay? So our final answer is radical 65 plus 2 radical 13. And we know we're done because we don't have a denominator that has a radical expression. Okay, next. 8 over 1 plus radical 3. So write the conjugate. 1 minus radical 3. 1 minus radical 3. We'll move it down so we'll have more space. Okay. So if you multiply the top together, you know what, I could just move this one over here. Okay. So if we multiply the top together, don't forget distribute. There you go. So 8 times 1 is 8 minus, that's not 24, 8 stays outside, and then you write a radical 3. Next, do your difference of two squares pattern. 1 times 1 is 1. Positive times negative is negative. So what is a radical 3 times radical 3? That's a radical 9. But what's radical 9? 3. Okay, oops. Now it looks a little bit different. So what is what is 1 minus negative 3? That will change to negative 2, right? Okay, now are we done? No. Why? Because 2 can actually divide the other, regular numbers or integers in the numerator. So you have to divide each of these two regular numbers, not the radical, the integers. So what is 8 divided by negative 2? That's negative 4. Then what's negative 8 divided by negative 2? That's positive 4, radical 3. So that's the simplest form. Okay. I think I can feel that some of you did not get that fully. Let me explain it again. So you can actually break this down into 8 over negative 2 minus 8 radical 3 over negative 2. Does that make sense? So 8 divided by negative 2, that's your negative 4. Okay. And then negative 8 divided by negative 2 is positive 4. This can't divide the 3 because that's a radical and that's an integer. Okay? So that's how you break this down. You divide the first expression by that, and then you divide the first expression by that as well. Alright. Well, what happens if 2 does not divide the number there? That's okay. Then this will just become a fraction, if that's the case. Okay, let's look at this one. Both have radicals. So the conjugate is radical 2, change it to minus, radical 7, and radical 2 minus radical 7. Alright, 12 is an integer. It's a radical. So integer outside, then radical, minus integer again, then the radical, over. Okay, what's radical 2 times radical 2? It's a radical 4. So what's radical 4? 2. That's weird. I'm talking to myself. Anyway. So radical 7 times radical 7 is a radical 49. It's radical 49? 7. But this should be minus. Okay, so 2 minus 7 is negative 5. So, let me just copy that over negative 5. Now this is my what if question earlier, right? So 5 can't divide the 12. Yeah? So is that the final answer? Well, yes, that's your final answer. Because the denominator cannot divide these integers anymore. Is there another way to write it? Yep. So another way to write it is, if you want to take out the negative, from the denominator, that will change the signs of these two. So pretty much you're multiplying the negative of the 5 to 12 and negative 12. So when you rearrange that, this will actually become positive and this will become negative. So you can have 12 radical 7 minus 12 radical 2 over 5. So what did I do? I multiplied negative times negative, it's positive. I made that, the leading term. And then negative times positive is negative. So pretty much I just switch them around so I won't have a negative at the denominator. That's another way of writing. Okay, it just depends on, how the possible answers or how the choices look like. Alright, so that's rationalizing the denominator.